So this question says that a company manufactures and sells X items per week, and the weekly price demand function is P. Price is 400 minus 0.4x times the number of items. So as the number of items goes up, the price goes down. And the weekly cost function is 2,000 plus 160x. And we want to know how many items should be manufactured and sold to maximize revenue, and how many items should be manufactured and sold to maximize profit. What is revenue? Revenue is the number of items sold, which is X, times the price, P. So this is important to remember. R is X times P. So in our case, X times 400 minus 0.4x. And we want to determine how many need to be sold in order to maximize profit. Well, we have our function, R of X is 400x minus 0.4x squared. Let's do this first using algebraic techniques. We'll do it the second time using the graphing calculator. And once we maximize revenue, we'll then go back and look at how do we maximize profit. So what do we have here? Again, our function for the revenue, R of X is 400x minus 0.4x squared. Let's switch the order. And let's write this as R of X is negative 0.4x squared plus 400x plus 0, just so it fits our same notion of ax squared plus bx plus c. If we have a quadratic function f of x is ax squared plus bx plus c. The vertex, which again, this has a leading negative term, so it's going to be opening that way. The vertex occurs at x equals negative b over 2a. So our vertex here, negative b, negative 400 over 2 times negative 0.4. So let's see what we get. We'll go to the graphing calculator and see where that gives us, what that gives us. So we need negative 400 on top. Here's our negative button down here. Negative 400 divided by 2 times negative 0.4. Use parentheses just so there's no issue. 2 times negative 0.4. And it gives us 500. So the vertex occurs at x equals 500. So that will be the point where the revenue is maximized. But what is the maximum revenue? The max revenue will be plugging 500 into that function. So again, we have R of X is 400x minus 0.4x squared, plugging in 500. R of 500 is 400 times 500 minus 0.4 times 500 squared. So let's do that on the graphing calculator. I'll just go ahead and I'll plug it in directly, then I'll show you a shortcut. 400 times 500 minus 0.4, or 0.4 if you prefer, times 500 squared. And we get 100,000. So max revenue is 100,000, we assume dollars, when 500 items are manufactured and sold. Well, nice problem, but we can also solve that directly with the graphing calculator. I'm going to plug this in to Y1 and find out when it reaches its maximum. So we did it with the vertex. We can also do it with the graphing calculator in the max finder. So we go back here. We go to y equals the function I want to maximize 400x 400x minus 0.4, minus button is there, negative button is there. Make sure you know the difference. Minus 0.4x squared. And I have that. I could look at a table maybe. That would be fun to try. Second table set. Let's start at 0, maybe go up 100, just to look at the behavior of the table. Second table. And you'll notice there's our shortcut, right? 500 led to a maximum value of 100,000. So that reinforces it. If you'd like to graph this, the window is going to be kind of tricky. I need to get as high as 100,000. I need to get as high as 500. So in terms of adjusting my window, I don't know, maybe 0 to 1,000. Scale it at 100, so every tick mark is going to be 100. I need to go up beyond 100,000, so I need some negative number. So the negative is here. Negative, I don't know, 20,000 maybe to 200,000. And the scale here, maybe 20,000 for the scale. The scale doesn't matter that much. But I'm going to hit graph and we're going to see it. And there we go. And I want to find the maximum. I expect the maximum to be 100,000 when x is 500. Second calc maximum is number 4. So move the cursor a little bit to the left of the maximum. Enter. Move it to the little bit of the right of the maximum. Enter. Move it on or close. And sure enough, the maximum is 100,000 when x is essentially 500. Don't worry about that 0.0009. That is a round off error of sorts on the calculator. Now that was the maximum revenue. Now what else do we need? We need the maximum profit. So to do that, we need to recognize that profit is revenue minus cost. Okay, so profit equals revenue minus cost. So our profit function, we'll call capital P of x. The revenue function, which you did on the previous example, was 400x minus 0.4 x squared. Our cost function, which we gave on the first page, cost function was 2,000 plus 160x minus 2,000 plus 160x. Let's simplify this a little bit if we can. We'll start with negative 0.4 x squared. 400x minus 160 is what, 240x minus 2,000. So this now we want to maximize, and let's play the same game we played before with ax squared plus bx plus c. We have a quadratic equation. Ax squared plus bx plus c, it's opening downwards, so we know we're going to have a maximum value. The vertex occurs at negative b over 2a. X is negative b over 2a. In this case, negative b, negative 240. Over 2 times negative 0.4. Let's go to the graphing calculator to see what that is. Second quit. Negative 240, negative is here. Negative 240 divided by parentheses 2 times negative 0.4. Negative button is there, 0.4. And we get 300. So the vertex occurs for the profit when x is 300. Now what is p of 300? We have p of x up here. P of 300 would be negative 0.4 times 300 squared plus 240 times 300 minus 2,000. Let's do that on the graphing calculator. So we get negative 0.4 times 300 squared plus 240 times 300 minus 2,000. And what do we get? 34,000. So let's go ahead and state the solution in context. Maximum profit of 34,000, we assume it's dollars. When 300 items are manufactured. And sold. But let's check that with the maximum finder on the calculator. So I'm going to plug this function, P of X, into the calculator and see if we get the same thing. Or even better yet, maybe I'll go ahead and I'll plug this one in before I simplified, just to see if I made any kind of error. So back to the graphing calculator. So to y equals, clear that out. So the first part is, remember, profit is revenue minus cost. Revenue 400x minus 0.4 x squared minus the cost minus parentheses 2,000 plus 160x. And we believe it occurs at 300. So my window, we'll see if my window is as good as it was before. Let me just hit graph and see what I get. I guess I can use that. It's not great, but the maximum is somewhere in there. Second calc, maximum is number 4. Move the cursor a little bit to the left of the maximum value. Enter. A little bit to the right of the maximum value. Enter. Close to the maximum value. And indeed, the maximum occurs when X is 300. When we sell 300 items, we get a max profit of 34,000, and that reinforces what we did using our concept of the vertex.